Okay, so today we're going to look at angle properties of circles, part 1. Part 2 is coming up. So last lesson we looked at chord properties of circles. So chord was a straight line passing or connecting two edges of a circle, but it doesn't have to pass through a diameter. Now we're going to look at the angles, do two theorems for today, and then we'll look at a few more next time. So the page reference to these theorems is page 131 in your textbook. If you just want to print that out and paste it into your rules book rather than copying it out. So circle theorem 1, which is what I call the compass, because it looks like a compass circle theorem. What it says is angles at the center and circumference. So that's the angle at the circumference and angle at the center. So there's a rule connecting them. So the angle at the center of a circle, this one here, is twice the angle at the circumference there. So the tip of your compass is half of what that bottom part of your compass is, or vice versa. It's twice as much. So for example, we've got here, if this is 70, the pointy bit's 70, then the base must be double it, so it's 140 degrees. So if your tip is 105 degrees, then the base is double that, which is 210 degrees. This one, 3, it might not look like the compass, but actually if you swing, I'll use red, if you swing at this point over here, like that, it's really... So that's 48 if you swing it across. So then that would become your compass shape. So just because when you first look at the shape, it doesn't look exactly like what you need or want, but you can always adjust it and imagine it. So that's the pointy bit, and that's 48. Then the base here is double that. So that's the first angle property, circle theorem. And you can either call it by using circle theorem 1, or the symbol we use is this compass symbol. Well, it looks like a compass to me. Circle theorem 2 says the angle in a semicircle is 90 degrees. Surprise, surprise. So all it's pretty much saying is you have a circle, you have a diameter, okay? And then you just link up that diameter with another point at the edge of a circle, doesn't matter where. That angle at that point C is always 90 degrees. So you first have to make sure you have a diameter to get the semicircle, and then create another point. In fact, if you created a point there, I'll call this point D, this would be 90 degrees because you have a semicircle. And the symbol, and the symbol for circle theorem 2 is literally you draw a miniature version of what you see. So you have a triangle inside the circle, and then it's 90 degrees there. So we're going to apply some of these. Oh, swipe. Okay. We're going to apply some of these circle theorems and be able to solve some problems. Again, in year 10, you just need to know how to apply, where to use them and how to use them. You don't need to know how to prove that these theorems are true. If you want to know how, come join us in year 11 and we can prove it together. So example 1, for reference, it's from page 132 of your textbook if you just want to cut and paste the diagrams. So example 1 says, find the pronumerals of the following circles. Alright, let's look at A. So we want this angle in the pointy bit, whereas we're told what the base bit is. So we don't have much to choose from this time. It's either circle theorem 1 or circle theorem 2. Well, the shape we've got looks like the compass shape, so we're going to apply circle theorem 1. So using circle theorem 1, or you can choose to draw the symbol. We know that angle BOC, so the flat base one, is twice of your pointy tip, so it's twice of angle BAC. So in other words, 126 degrees is 2 lots of A degrees, so A degrees is half of 126. So that's what, 63 degrees. So in terms of setting out with these circle or chord theorem questions, state what the theorem says. So in this case, you have that the base angle is twice the pointy angle, the tip angle. State what theorem you're using or why. So you'll get a tick for that. So in this case, we're using circle theorem 1, or you can choose or you can choose to draw the symbol as well. Then substitute your values and then solve it. So 1 tick for the what theorem you're using or why this is true. 1 tick for the statement of what the theorem says, substitution, and answer. Okay, let's do part B. Drop space. Yeah, I can squish it in. I'll just squish part B down here. Alright, part B says find what this A value is. Okay, fair enough. We've got a triangle ABC. In fact, AC is a diameter, so it spans across, and so this we have a semicircle. So using circle theorem number 2, if I have a semicircle, a diameter, and then I'm creating a triangle where the third point of the triangle is at the edge of the circle, then that angle must be 90 degrees. And since we have a triangle, then A plus 90 degrees plus 70 degrees must be 180 degrees. So we can use that to solve what A is. Okay, so let's change it to blue. Alright, so first of all, state what circle theorem you're using. So using circle theorem 2, or you can draw the symbol. So it's like that, remember? So what do we know based on the circle theorem? Well, we know that angle ABC, that corner edge, that corner angle, must be 90 degrees. Okay. Now, next step is, because we're dealing with a triangle, ABC, we know that the sums of the angles in the triangle is 180 degrees. So we know that angle ABC plus angle BCA plus angle CAB must equal 180 degrees. Why? Because remember that symbol, the sum of all angles in the triangle. So ABC is 90 degrees, BCA is 70 degrees, and CAB is what we want to find. A degrees is 180 degrees, so in other words, A is 180 minus 90 minus 70. So A degrees must be 20 degrees. So again, in terms of marking scheme, you get a tick for explaining what theorem you're using, or what the theorem says. And in this case, we've got to further apply the idea of sum of angles in a triangle is 180 degrees, and then hence with substitution we can work out what that missing angle is. Alright, let's do one more example. So here we need to work out what the angle ACB is, so this pointy tip. Alright, so we've got a circle. We've got a pointy tip. That suggests that we should use the compass or circle theorem number 1. So if we want this pointy tip angle, then by chord theorem 1 we need that base angle as well, because we know that's twice the pointy tip angle. Okay, well, if we want that base angle there, well then let's consider this triangle here. Because if I can work out what this angle is, and then I can do 180 take away, the sum of these two angles, and then I can find out what that base angle is of the compass, and then I can use it to find what that pointy tip angle is. So let's make some observations regarding this shape. or the bottom triangle at the very least, because we need to use it. So looking at this triangle, well, what do we know? Well, yes, okay, this angle is 25 degrees. Cool. But if you look at it, O is the center of a circle. Center, OA, OB. So these two lines are connected back to the circle. So remember, a line that joins the edge of a circle to the center of a circle is a radius. So, and all radius must have the same length. So in other words, this side length must be the same as that side length there. Which means that, hey, if you have a triangle of two side lengths which are equal, it's an isosceles triangle. If it's an isosceles triangle, then this corner angle must be the same as that corner angle. So this must be 25 degrees also. Well, hey, we've got two other free angles in the triangle, so we can then work out what this base part of the compass angle is. So that's 180, take away 25, take away 25. And then we can then work out what this pointy tip part of the compass is, because it's going to be half that because of circle theorem number 1. And that's essentially the idea of solving this question. So now the next part is, how do we set it out so we get the full marks? Okay, so let's go back to our first observation that, hey, OA is the same distance as OB. Why? Because they're both radiuses, or radii. Well, if OA is the same as OB, then that means triangle AOB is isosceles. Well, that's not how you spell isosceles. Isosceles. If that bottom triangle is isosceles, which means the two angles, angle OAB is equal to angle OBA, which we know must be 25 degrees. Okay, so then we also know that the sum of angles in a triangle must be 180 degrees. So in other words, OAB plus angle OBA plus angle AOB must be 180 degrees. Why? Because sum of angles in a triangle is 180 degrees. So make sure you draw the symbol to explain why. Let's substitute. So AOB is 25 degrees, OBA is 25 degrees, AOB, we don't know what it is. Well, in fact, we can just, we'll just try and work it out. So angle AOB is 180 degrees. So angle AOB is 180, take 25, take 25. In other words, angle AOB is 130 degrees. Okay, so we've got the base angle of the compass circle theorem. So then we can say that using circle theorem 1, or you can draw the symbol. Using circle theorem 1, well, what do we know? We know that the base part, so angle AOB, is twice as the pointy tip angle, which is angle ACB. In other words, 130 degrees is twice of the angle we need to find. So therefore, angle ACB is half of 130. In other words, angle ACB must be 65 degrees. And that's pretty much it for circle theorems part 1. So just learning how to apply the compass one, circle theorem 1, and circle theorem 2, which is it's 90 degrees given a semicircle. So make sure in the setting out you explain which circle theorem you're using, or you can draw the symbol. Write down what you see or what this theorem tells you, and then you can substitute and then solve. If necessary, you might need to apply the sum of all angles in a triangle is 180 degrees to do some further calculations. And you might need to use some properties of circles that we talked about last lesson. For example, the statement that OA and OB are the radius, and hence we know they have the same length. So to-do list, is that. That's it. Good luck. Have fun.